Now that you know how to simplify radical expressions, we're going to look at operating with them. The first thing I want to look at is adding and subtracting with them. If you're adding, so if we look at the example, 2 square roots of 2 and 6 square roots of 2, you want to combine your coefficients. So that's the 6 and the 2. If I have 2 square roots of 2 on the left and 6 of them on the right, how many do I have total? 2 plus 6 is 8, so that would be 8 square roots of 2. Subtraction is the same thing, except instead of adding the coefficients, you're subtracting the coefficients. So if I have 4 square roots of 5 minus 2 square roots of 5, if I have 4 of them on the left and I'm taking away 2 of them, I combine my coefficients, 4 minus 2, which is 2, because I would have 2 of them left if I took away 2 of them from 4 of them. So let's take a look at some of these. These ones aren't necessarily as easy because the numbers underneath the radical symbols, the radicands, are not the same. So I have to simplify them first. So if we're looking at the square root of 80, the biggest perfect square that I can use with 80 is 16. So I would have the square root of 80 be the square root of 16 times the square root of 5. That's 5, sorry, minus, and then 45, I could simplify. The biggest square root, perfect square would be 9, so it'd be the square root of 9 times the square root of 5. I could take the square roots that I can, so I know the square root of 16. The square root of 16 is 4, so I would have then 4 square roots of 5 minus the square root of 9 is the one I can take over here, so that's 3, and then I don't know the square roots of 5. So I'd have 4 square roots of 5 minus 3 square roots of 5. Now I can be able to combine my coefficients to 4 minus 3, which gives me 1. So my answer would be 1 square root of 5, or just the square root of 5. So you have to break it down so that you have like terms underneath the radicands in order to be able to actually subtract your coefficients. If you do not have like terms, you cannot add or subtract the coefficients. Let's take a look at one more. If I break down 72, the biggest perfect square that I can break down 72 with is 36. So I can say the square root of 72 is the square root of 36 times the square root of 2 minus 18. 18, the biggest perfect square I can use is 9, so it's 9 times the square root of 2. I take the square roots that I know. The square root of 36 is 6, so it's 6 square roots of 2 minus 9 is a square root I know, which is 3, so then that's minus 3 square roots of 2. My radicands are alike, they're both the square root of 2, so now I can combine my coefficients, so 6 minus 3 is 3, so I would have 3 square roots of 2 as my final simplified answer. Multiplication, remember the multiplication property of radicals before said if you have a number underneath the radical symbol, you can take it apart by multiplying the square root of each piece. Well, we can now go backwards from that. If we have this 2 square roots being multiplied by each other, we can use it backwards and we can combine it to be one perfect square root. So if I had the square root of 2 times square root of 8, I could say that's the square root of 2 times 8, which is the square root of 16. And when we would simplify that, that would be equal to 4. If we're looking at this next example, I would have to use the distributive property. I would have to use the distributive property to multiply the 5 by the square root of 2 and the square root of 3 by the square root of 2. So if I multiply 5 by the square root of 2, that'd be the 5 times square root of 2 because I don't know what the square root of 2 is. But then the square root of 2 times the square root of 3, I multiply them together, gives me the square root of 2 times 3, which gives me the square root of 6. So I would have minus the square root of 6. This cannot be simplified because the radicands, the number underneath the square root symbols, are not the same. So they're not like terms, so I can't say that I can combine my coefficients. The division one. This one is probably the hardest that you have to work with. So if we're looking at this one says the square root of 3 over 5. You cannot have a square root in the denominator of a fraction. So you'd have to take the denominator and multiply both parts of the fraction by the denominator. So that's why in this step here, that they are multiplying both the top and the bottom of the original fraction by the denominator, which is the square root of 5. We don't know what the square root of 5 is, so my numerator becomes 3 times the square root of 5, and my denominator, based on that property we just talked about, the square root of 5 times the square root of 5 is the square root of 5 times 5, or the square root of 25, which is 5. So my final answer is 3 square roots of 5 over 5. And then that cannot be simplified further, because if we look at just the fractional piece without the radical, 3/5 cannot be simplified. So let's take a look at another one. If we have 2 over the square root of 2, I want to take both sides of that and I want to multiply it by my denominator to get rid of it. So I would have 2 over the square root of 2 times the square root of 2, and I want to multiply that by the square root of 2 as well. So 2 times the square roots of 2 is 2 square roots of 2. And then if we just do that piece, the square root of 2 times the square root of 2 gives me the square root of 2 times 2, which is the same thing as the square root of 4. So this is over the square root of 4. So now if I simplify this, I can't simplify 2 square roots of 2 because 2 is as simplified as it can get. So I'd have 2 square roots of 2 as my numerator, and then my denominator is the square root of 4, which is 2. And then if I just look at the fraction part, right, that is the square root of 2, or not the square root of 2, I'm sorry, that's just 2 over 2. The square root of 2 is taken off for a moment. 2 over 2 simplifies to 1, so remember, when your numerator and denominator are the same, they cancel out. So we're left with just the square root of 2 as my final answer.